Hi, welcome back. Second episode, Web Service Design. So this is our series on Web Service Design, and we already covered some basics in the first episode. We talked about the standards we follow, etc., and how we document our web services, and we have a request, a processing block, a response. How do we structure the JSON data structures in the request and in the response. We've talked about how the response contains three components in the data structure. There is a status, there is a data block, and there is a messages array. We've also gone through the fields of the messages array, and as I'm sure you have noticed if you watched that episode, the messages array is interesting and captures a lot of our learning over the last several years about how to communicate error messages from a web service to the calling code. So now we have done all that. Now we are getting into the guidelines of how do we design our web services within the framework defined by the standards. So the guidelines. We have now a list of 20 guidelines that I am going to put on the table in front of you. Some will take a lot of time, and some will take an entire episode, and some will be brief. Okay. So the 0th guideline, actually we have 21 because I think we are going from 0 to 20. Good catch. So 0th guideline. Emphasize that this is the 0th because this is the very first thing you need to do. It has nothing to do directly with any web service. When we develop applications in Remiges, when we design the software, the code, the bits and bytes of any application in our company, we have 5 dictionaries. These 5 dictionaries are fundamental on which our software is designed and built. So what are these 5 dictionaries? The first one is a set of constants. The constants which are used in the code anywhere. For instance, you want to keep a constant saying the maximum age or the maximum dimension or the list of certain values or whatever it is that you wish to use. The types, yes, a good example is types. The types of, say, a transaction or the types of a purchase order. A purchase order can have 5 types. Now, where does that 5 go? It has to go into the constants somewhere because you cannot dynamically add a 6th type and the 7th type, right? These are constants. When you add a new type to the list of purchase order types, your software overall has to change. You can't treat it as data. So this goes into constants. These are, so one of the basic, very, high school type of hygiene rules for software is that you cannot have literal constants in your software. You cannot embed a literal string or a literal integer in the source code. You have to have a symbolic name for it and refer to that value through the symbolic name. So all these symbolic constants go into the dictionary of constants. The second dictionary is the dictionary of error codes. We've already talked about some 15-20 error codes being sufficient to handle almost every situation of every web service. Sometimes you need to add a few more, but that list of 15, 20, 25, 30 error codes has to be defined as a separate dictionary of constants. Because if 5 web services return a particular error code, then all 5 of them have to refer to that error code using the same symbolic constant. The third dictionary is the internationalization strings, which are keyed by language code. We've already talked about one place where we see these strings, that is the place where messages are being reported. When a web service reports errors, it sends a human readable message, but not the message itself. It sends a message ID. The message string which maps to that message ID is in various languages. So we have an internationalization string table. That is the third dictionary. The fourth dictionary is editable configuration parameters. So this is very different from constants. Constants are constants because you cannot change them without changing other parts of your source code. Editable configuration parameters are more like policies. I'll give you an example. We do not wish to accept a new voucher entry into the system if the voucher's date is more than 1 month older than today. This 1 month could be a configurable parameter. Today you have a policy of 1 month. Tomorrow you may wish to change the policy to 45 days. So configuration parameters which can be changed without changing the source code are called editable configuration parameters. These are a 4th dictionary. The 5th dictionary is a set of SQL statements. SQL statements are not embedded randomly, strewn around in the software. They are defined in one place. They are audited separately. A lot of performance issues depend upon how the SQL statements are framed, how they are written. And therefore, they need to be given special scrutiny and special status. And we have a separate dictionary for SQL statements alone. This doesn't mean that I can go and change an SQL statement of my application without rebuilding the software. No, we need to rebuild, but at least the SQL statements are in one separate table. So that's the 5th dictionary. So these 5 dictionaries are set up when we start writing the specifications for the web services of any application. Interestingly, the editable configuration parameters are made editable in most of our applications, most of our projects, by using a separate product. One of the products that we have called Rigel. Rigel is an open source product. You are welcome to use it for all your projects, but it is basically a repository of editable configuration parameters which are maintained in a separate store, separate from the main database where the application keeps its data. So it has its own UI. Rigel allows you to change the value of a parameter. Rigel tracks the audit trail of changes made to every parameter and so on and so forth, and it makes editable configuration parameters a very convenient aspect of your business application. So much for Rigel. We will now jump into the next point in our list of guidelines. Okay? The next point is a very special type of web service, the list call. And I will explain as we go along now over the next few minutes why the list call is such a big deal. Now, to be able to understand what a list call is, let's just sort of see where it fits in with web services in general. See, for most object classes in your application, let us say you're writing a financial accounting application. You will have accounts, you will have ledgers, you will have customers, you will have vendors. Those are all object classes, right? So you can call them masters. Those object classes will require web services for creating new accounts, a web service for listing all the accounts which match certain criteria, the web service to get all the details of one account, the web service to update an existing account, a web service to delete an account, and so on. So these are very common, what we call CRUD operations are a very common set of web services for applying, operating with any kind of objects. The second type of web services will be to handle transaction data. Like I create a new transaction, so I'm logging it into the transaction repository. I'm updating a transaction, I'm reversing a transaction, etc., etc. Those will be all sorts of web service calls. Then we'll have web services which generate reports, or lots of other types of calls. This is by no means exhaustive. Depending upon the complexity and variety of your business application, you will have lots of different types of web services. But one of the basic types which is there in all business applications is list. List this and list that. List the users. Give me a list of users. Give me a list of accounts. Give me a list of transactions in an account. Give me a list of members. Give me a list of ledgers, right? So the list call is a very popular fixture of the suite of web services of any business application. So what's special about a list web service? There are certain challenges which we have faced, and that gets reflected in what I'm going to explain now. See, this is an example of a request to a list web service. If you see this request, you'll see that this is a big JSON data structure which has lots of fields. I'm going to try to make sense of this list of fields for you. Now, most of these fields are filters. So what happens is these parameters specify to the system, give me those objects whose XYZ field matches a particular value, whose ABC field matches a particular value, etc., etc. So let's look at it a little more closely. Look at this set of parameters. This set of parameters specifies all sorts of filters by which I will request a subset of the records. So I am saying, give me those accounts whose client ID is 23. Give me those accounts which are to which the channel 143, the channel number 143 belongs. Give me those accounts whose priority is 0, etc., etc. So these are all parameters which are being used to identify a subset of records which will be returned in the call. So far so good, right? Everywhere you write web services, you need to have these calls. List calls are the ones where you get a list of matching records. Within this set of filter parameters, look at this this pair of parameters, this dispatched from and dispatched to. So here what we are specifying is, maybe there is an attribute called dispatched at. So there is an attribute in every record called dispatched at, and what we are asking for here is, get me those records whose dispatched at field has a value which is after dispatched from and before dispatched to. So this is a range. So dispatched from and dispatched to taken together specify a range of values and give me the records whose dispatched at field has a value which falls inside this range. Similar example, size from and size to. Assume that all the records have an attribute called size. And here we are asking the system to return us only those records whose size value falls between the size from and size to, which I am giving here. So all of these are parameters which you have to specify for getting a filtered set out of a list call. So what I am trying to explain here is that there are certain filter parameters that you specify in the request which will do an exact match, like client 23. So give me those records whose client ID is 23. So that's where you're looking for an exact match. But wherever there are attributes in the records which are a kind of quantity or a kind of date and timestamp, there you may not want to give an exact match, you may want to give a range. Even if it's a very narrow range, it is safer to give a range and then pull out the matching records than give an exact match, because even if you're off by 1 second or in some amount field, if you're off by 0.01, the exact match will fall through. So you want to give ranges. So when we give ranges, we have these fields which have field names in the request which end in from and to. So this is how we give ranges. So far so good when it comes to the filter parameters. Okay. Now the filter parameters are only one part of a list call. The next part, the fields parameter. When you request for a set of records from a database which has, say, millions of records, each record may have 150 fields. But you may not be interested in all 150 right now. You may be interested in only 5 fields. So you are asking the system to vertically slice certain columns from 150 columns so that you can pull out the 5 fields which you want. So in order to specify that, when we design list web services, we add an input parameter called fields. The fields parameter is an array of field names. So it is used to get me, I specify the fields parameter, to get me just the fields that I need. I don't want all the fields. It would slow down the system, and I would have to discard the data at my end. It would just slow down both ends, the front end and back end. So I want only the fields that I want. We make it flexible by having a fields parameter. So the list of valid field names must be part of the constants dictionary. We have already talked about dictionaries, right? So one of the constants in the set of constants is the list of valid field names. So the value of this constant will be an array, and you will have the list of valid field names against which the web service will check the values passed in the fields parameter. That is how we validate whether these field names are valid field names or not. The SQL query is a bit of a challenge for a flexible fields call, because this is not a static SQL query anymore. To be able to pull out data for the matching records with the matching field names, you will have to build the SQL statement dynamically based on the parameters in the request. I'll repeat, this is something to think about. If you are using SQL to pull out data from a database table, then the SQL statement probably in the list calls, the SQL statement may not be static, may not be possible to get what you need by using a static query, because the filter parameters change, the list of fields that you want also change. So you may actually have to dynamically create the SQL string and then throw that string at the database and pull the correct records out. So you don't need a fields parameter if you have less than, say, 8 or 10 fields in the object to begin with. But if the object has 150 fields, then you definitely need a fields parameter in the list web service. The next dimension in the list web service is the sorting. So the sorting is very important to get the data in the order in which you want, and get also to do the slicing and dicing horizontally. The fields parameter is vertical slicing. It selects a subset of columns from the set of 200 columns. The horizontal slicing and dicing is for me to pull out 50 records at a time when I know that the software, the database has 100 million records. So horizontal slicing and dicing is required, vertical slicing is done using fields, and there is also the issue of sorting. Let us go look at an example and look closely at a few parameters which do all this for a list web service. Look at these parameters. We have 5 parameters here. We have 5 parameters here. The first parameter is the fields array. The fields array specifies, this is an input parameter in the request of the list call. This specifies to the server, give me only these fields. And the server, the web service code, will actually compare each element in this list against that constant which specifies the list of valid fields for the list call. So this list must have values which are included in that constant meta list which is there in the constants table. And if you have any field name here which is not specified there, then the system knows that it has to, that's an error, it has to return an error. So the first parameter is the fields column, fields parameter. The second is sort direction. Sort dir is sort direction. Dir here is not directory, it's direction. A means ascending, D means descending. So the sort dir parameter is specified as an input parameter, and it can have either the value A or D, nothing else. Sort by gives a field name. Now, sort by doesn't have to specify a field name which is included in the fields parameter. It just has to specify a valid field name. But this field will be used by the database to sort the data and then return it. And after the sorting happens, the next filter is the horizontal slicing from row and to row. So in this example, we are seeing from row 701 to row 800. So this is what is used to slice out a set of 100 matching records from the 701th record to the 800th record. So these 5 parameters show an interesting aspect of all list calls: the fields, the sorting, and the horizontal slicing. Vertical slicing, sorting and horizontal slicing. The next angle is the count parameter for list calls. We have begun to experience certain situations where the count parameter is very useful. What does a count parameter do? Sometimes I want to simply apply certain filters to a list call. I want to apply certain filters to a large set of records, and I simply want to know how many records are there which match my filter criteria. So I don't want the records, not even horizontally, vertically sliced a subset of the fields of the record. I don't want the records at all. I just want to know how many records are there in the database. So the count parameter becomes very useful for this. Okay. So what we do is, in the request, we add a parameter called count only, which is Boolean. And if count only is true, it means I'm not interested in the records, I'm only interested in the count of matching records. And the fields parameter, the sorting parameter, the horizontal slicing parameters are all ignored if count is equal to true. Now let's look at this. In this example, there is a list call here. At the bottom you are seeing count only equals F for false. So count only is being set for false here, okay, and set to false, which means that I don't want a count, I want the actual records. But when I want only the count, I will set count only to true. And this is the field I was talking about, the count only field, okay. It's been set to false here. Now this is an example of a response that comes when the count only has been set to true. In the response, you will get a field called count. There is a mistake I have seen in some teams which have tried to implement this, where the name of the response field is also count only. The name of the field in the request is count only, which means only give me counts. But the name of the field in the response should not be count only, it should be count, because this is the response to that request. And here we are seeing the system has returned with a count, that is 85,235. It means that there was a list call made and some filter parameters were given, and there were probably very large numbers of records, and the set of matching records is 85,235. So sometimes this becomes very useful. So we have reached the end of episode 2. We will jump to the next set of guidelines in our next episode. Thanks for watching, and really look forward to having you back again for episode 3.